Good afternoon, ladies and gentlemen, and welcome to the formal debate today. The motion for today is resolved that synthetic division is an easier method than remainder theorem. Before we start our informal debate, may I call on Alexandria P. Hansilan to lead the prayer. May I request everyone to stand?
Let us all pray. Dear God, we are so thankful that we are all gathered here today. We thank you, God, for the knowledge and guidance you have showered upon us. We will be having an activity this afternoon, O God. Grant us peace and cooperation within ourselves so that love and joy will be shared and cherished this afternoon. O God, please bless all the people behind all of this, our teachers, staffs, and all my classmates. May you forgive us for all the sins that we had committed. All of this we ask. In the mighty name of Jesus we pray. Amen.
Amen. Before we start our informal debate, may I call on Sir Roderick Palmaras for our opening remarks.
Okay, you may have your seat first. Okay, once again, good afternoon to all the students. And I would like to say thank you also to our Board of Judges for this afternoon's informal debate. So we have Ma'am Jane Fermin, our master teacher, our department head in mathematics, Ma'am Laila Encarnacion, our math teacher, and also another math teacher, we have Ma'am Mary Ann Banya. So they will serve as our judges for this afternoon's informal debate. So the topic that we, in our debate this afternoon, is all about resolve that the synthetic division is easier method than the remainder theorem to find the remainder of the polynomial. So this time I would like to congratulate in advance the affirmative side and the negative side. So we have to concentrate, relax, and be participative. So once again, good afternoon.
On my right side are the affirmative team, Miss Pia Pebeso, Miss Sara Damundo, Miss Janine Carla Dupra, Mr. Benny Aldrihara, Miss Leslie Avila, and Miss Antoinette Medisares. On my left side, the opposition team, Checa Guevara, Miss Lady May Espisen, Miss Alessandra Jacob, Mr. Carl David Macabio, Miss Dency Jane Lames, and Miss Alex Andrea Hansino. Okay. At this point, we are now going to start the informal debate. May I call on Miss Kia Pibeso to open the motion.
Good afternoon, everyone. We are strongly convinced that synthetic division is easier than remainder theorem. It is because synthetic division is a method or shortcut method of dividing polynomials. It is generally used especially in finding the roots or zeros of a polynomial.
The remainder theorem is the process of dividing a polynomial f of x by a polynomial d of x and finding the remainder. This written as f of x is equal to q of x times d of x plus fi plus r of x, where f of x is the dividend, q of x is the quotient, d of x is the divisor, and r of x is the remainder. The remainder theorem takes this one step further and states that if a polynomial f of x divided in a linear equation or a linear divisor x minus a, the remainder is going to become f of a.
Synthetic division is much easier. Let me show you the procedure. The equation is x cubed plus 4x squared minus 5x plus 3 divided by x minus 2. So, by using synthetic division, we just get all the variables and plot them like this. Just bring down the first constant, then multiply the divisor. Then 1 times 2 equals to 2, then add by 4 equals 6. Then repeat it all until the last part. Then it's done. We already have the remainder in that simple way. Therefore, synthetic division is much easier.
The remainder theorem is much more easier. Let me show you the example. The equation x cubed plus 4x squared minus 5 plus 3 divided by x minus 2. So f of x is equal to x cubed plus 4x squared minus 5x plus 3. So the value of x is positive 2 because so we transpose it by 2. So 2 cubed plus 4 2 divided by 2 cubed plus 4 times 2 is equal to 16. 45 multiply by 5 by 2. So 10. Bring down 3. So we add all the same signs. So 8 plus 16 plus 3 is equal to 27. And bring down 10. So 27 minus 10 is equal to 17. The remainder theorem states that when a polynomial f of x is divided by a linear polynomial x minus a, the remainder of the division will be equivalent to f of a. In other words, if you want to evaluate the function f of x for a given number, you can divide the function by x minus a and your remainder will be equal to f of a.
But for me, I strongly convince you that synthetic division is much easier method than remainder theorem because this method has been incorporated into a technique called the SN synthetic acceleration for accelerating the iterative solution of two-dimensional discrete ordinate equations. For model problems, convergence of the method is established and bounds on the rate of convergence obtained. The analytical results coupled with numerical results for more general problems indicate that the SN synthetic method technique is extremely effective for problems containing large regions where the ratio of the scattering total cross-section is close to unity.
I strongly disagree that synthetic division is easier than remainder theorem because using remainder theorem, we can redefine a root as a value a for which factor quantity x minus a divides through the polynomial p of x to get the remainder of 0. In other words, it divides through the polynomial completely. The remainder theorem especially refers in finding the roots of a polynomial of a large degree like 4 or more by finding the first root and using it to synthetically divide through the polynomial, we are able to contain smaller polynomial for which we repeat the process, we can find the last root. Thank you.
Synthetic division is much easier because it generalizes to division by any monic polynomial and to any polynomial. The advantages of synthetic division are that it follows one to calculate without writing variables. It uses few calculations, and it takes significantly less space on paper than long division.
Yes, using the remainder theorem is a long process, but you can learn more and may be able to apply all you've learned. Like how to solve if there's a variable and how to use the signs.
In order to divide polynomials using synthetic division, you must be dividing by a linear expression and the leading coefficient must be a 1. For example, you can use synthetic division to divide by x plus 3 or x minus 6. But you cannot use synthetic division to divide by x squared plus 2 or 3x squared minus x plus 7. If the leading coefficient is not a 1, then you must divide by the leading coefficient to turn the leading coefficient into a 1. For example, 3x minus 1 would become x minus 1/3, and 2x plus 7 would become x plus 7 over 2. If synthetic division will not work, then you must use long division.
Not all equation can solve using synthetic division. As what you said, for example, the given is 3x minus 1, it would become x minus 1 over 3. And 2x plus 7 would become x plus 7 over 2. If the synthetic division will not work, then you must use long division or the remainder theorem. The remainder theorem states that if you divide the polynomial f of x by x minus h, then the remainder is f of h. The theorem states that our remainder is equal to f of h. Therefore, we do not need to use long division, just need to evaluate the polynomial when x is equal to h to find the remainder.
I am strongly convinced that synthetic division is much easier than remainder theorem. We all know that long division is useful with the remainder and factor theorems, but long division can be time-consuming. To divide a polynomial by a binomial and compute the remainder, we can use synthetic division. We can divide by a binomial whose leading coefficient is 1. We must factor the leading coefficient without the binomial and divide by the leading coefficient separately.
The remainder theorem states the fact that when you divide a polynomial p of x by any factor x minus a, which is not necessarily a polynomial, you'll obtain a new smaller polynomial and the remainder. And this remainder is the value of p of x and x is equal to a. Remainder theorem operates on the fact that a polynomial is completely divisible once it's factored to obtain smaller polynomial and the remainder of 0. This provides an easy to test whether value a is the root of a polynomial p of x.
We acknowledge also the presence of Ma'am Annalyn Fergal. Ma'am, thank you for coming. Thank you for the wonderful defense for the chosen sides for the task that we assigned to you. So now, anyone from the audience who have their opinions regarding to the topic? Anyone? Okay.
How can you prove that using the remainder theorem is easier than using synthetic division?
Okay, thank you for your question. Well, like what we've said, that synthetic method is easier than remainder theorem. It is because, like what Antoinette examples earlier, it is easy, right? Because you just have to get the numerical coefficient and find the value of x. In just a second, you will get the remainder if you will use that method. And in addition, it is also effective if the given equations contains large equations.
From the other side?
Nakita natin sa kanilang mga example na ang remainder theorem ang pinakamadali kasi bukod sa marami kang matutunan dito, magagamit mo rin malalaman mo kung paano gamitin ang mga variables. Magagamit mo rin kung paano gamitin ang signs. Tapos, in this theorem, you don't have to understand about the proof of theorem. You need to understand how to use it. Thank you.
Any other opinions or questions? Okay, Miss Sheena Katahay.
How can you say that remainder theorem is more than important than synthetic.
Anyone from the debaters? Miss Janine Carlos. Anyone from the debaters? Okay, anyone from the affirmative and opposing team? Okay. Let Sheena again repeat her question.
How can you say that remainder theorem is more than important than synthetic?
Okay. How can you say? From the opposition team?
Remainder theorem is
How can you say that remainder theorem is more than important than
because kaya nga marami tayong matutunan. Kasi nga 'di ba nagagamit natin ang variable. Malalaman natin kung paano gamitin ang variable sa pamamagitan ng pagsusolve. At magagamit rin natin ng maayos. At kung maaari mong i-apply ang mga signs na nalalaman mo para makuha ang
Okay, Miss Janine Carlos.
Synthetic division is more important than remainder theorem because if you don't have enough time to solve that problem, you can use synthetic division because it is a shortcut method.
Yes, it is a shortcut method. Kasi hindi lahat ng mahabang proseso may shortcut. Hindi lahat ng, like sa buhay. Kasi ang math hindi lang siya hindi lang siya isang subject, kundi ang math pwede mo rin i-apply sa real life. Hindi lahat ng mga problema kaya mong lagpasan ng madali. Presto yun sa math. Hindi lahat ng mahabang proseso may shortcut. Kasi nga, mahabang proseso, mas pipiliin ko ang mahabang proseso kasi alam ko ang bawat proseso nito, alam ko kung paano ko siya i-solve. So, para sa akin, mas madali ang mahabang proseso kasi pag sinagot mo ito, wala kang doubt na magkamali ka kasi kapag sasagot ka ng mabang proseso, gentle ka, maingat ka sa pagsagot. Tapos pag shortcut naman, syempre, pinili mo yung madali. So, mamadaliin mo rin yung trabaho. Kaya mas pipiliin ko dito kasi nag-iingat ako ng sagot. Kaya sinisigurado ko na mas.
Okay. Mr.
Kaya nga ginawa ang shortcut para mas mapadali ang trabaho. Kagaya na lang sa exam, 'di ba? Halimbawa, 60 minutes lang yung time tapos puro solving pa. So anong gagawin mo? Puro ka na lang long method. Dapat din may shortcut din para hindi naman tayo kapusin sa oras.
What if hindi required ang short na ito?
Kaya nga ginawa ang shortcut method para mapadali ang trabaho. Hindi naman yun kuro-kuro lang kasi tested and proven naman yung shortcut method.
Wala na? Wala na sa opposition team? Spise? We know that you have a thoughts about what Benny said earlier. A while ago.
Okay. Hindi siya magiging long method ang remainder theorem kung although long method ang remainder theorem, kapag alam mo ang bawat procedure ng remainder theorem, mas madali mo itong solve kung kung alam mo naman yung proseso niya, mas madali mo lang siya kasi kailangan mo lang i-substitute lang ang x.
For being assigned as your guts here in your informal debate, I want to know which is which kay nahirapan ni kayo mag-grade. Using synthetic division, you find out that the remainder is 17, right? Then using remainder theorem, you find out that the remainder is 17. I want to know what is the advantage of using synthetic division compared to remainder theorem from the affirmative and from the negative group.
Okay. Floor is for the mathematics side.
Advantage.
The advantage of using synthetic division. Okay.
The advantage of synthetic division, ma'am, is because it is a shortcut method. You can easily get the remainder just in that method.
How about the remainder theorem is still a shortcut?
Yes.
Right?
Ma'am, as you asked, what is the advantage of synthetic division to remainder theorem while there are both shortcuts? Well, in synthetic division, ma'am, we stick up to the plot and the remainder theorem may cost more time. So that is the advantage of synthetic division. We can use it much easier and very faster than the remainder theorem.
Okay, from the negative side. Defend your
The advantage of theorem is alam mo kung paano i-solve yung problem na may variables, ma'am. Magagamit mo yung sign na alam mo kasi.
What is the importance of variable in that problem? Why is it the need for us to use that variable? Okay, in synthetic division, we disregard the variable, right? But in the remainder theorem, we use the variable. What is the importance of using the variable or substituting the variable?
Important ang variable, ma'am, kasi x, ma'am, pag sinasang x, ma'am, kailangan sang variable kasi f of x, kailangan ng variable, yung variable na siya, ma'am, kailangan may substitutes kung i-substitute kung ano yung value ng variable na yan.
What is the relation of that to your real life situation or to your life as a student? Is there any relation? What? Can you relate that one to your real life situation now?
Yes, ma'am, we can relate synthetic division to our real life as a student. It is because we were saying that don't make simple things complicated. If you have the simplest way, choose the simplest way than the complicated.
How about the negative side?
Ano, ma'am? About the madali o kaya. Ang madali kasi, ma'am, sinasabi nila na madali yun, mabilis matapos. Ito sinasabi nila na hindi long method. Hindi naman din about sa ano, ma'am, madali, kundi about din sa kung kaya mo ba. Kasi iba ang madali sa kaya. Kasi yung madali sabihin, hindi kayang gawin na yun. Yun yung kaya.
Any questions for the board of the may question po kayo.
Nahuya.
Wala na po yung
Okay, we just heard your opinions and your ideas with our debate. So let's clap our hands for the opposition side and also for the negative side. So this time, let's hear, of course, the comments and the suggestions of one of our judges, our math department head, our master teacher 2, Ma'am Jean P. Fermi.
So, as what I have seen in your example, using synthetic division, is it, what do you call that 1, 6, 7, and 17? Yung sa bottom. Yung sa baba. That is the second, the first equation that you have, tama? Yung equation na nakuha ninyo, the only advantage of using synthetic division is that you can determine the second equation. So, in ang 1, 6, 7, and 17, 1 is x to the second power plus 6x plus 7 and the remainder is 17. Tama?
Yes, ma'am.
That is your quotient. You can determine the quotient using synthetic division. the other factor. Tama? While in remainder theorem, you only find the remainder which is 17. And you can say that the implication of that 17 is that x minus 2 is not a factor of equation f of x is equal, function f of x is equal to x cubed plus 4x squared minus 5x plus 3. Tama? So, hindi siya factor because the remainder is not 0. Ang munang implication, dira, nakuha nyo? The only advantage of using synthetic is you will know the divisor. While using the remainder theorem, you will not know the divisor, but you know the remainder, which is 17. And you can now assume that x minus 2 is not a factor of the function. Tama? Okay. But they are all shortcuts. Lahat yan silang shortcut. Ang advantage ng remainder is you know how to substitute. And applying it to real life situation, it's applying it to your life as a student, dapat you will not, do not make haste. Yung nagmamadali kayo, dapat make sure in substituting. So sa mga decision sa buhay, dapat sigurado kayo palagi. Tama?
Yes, ma'am.
Salamat.
Together sa ating tatlong members of the Board of Judges. So once again, thank you. Okay, so this time, I have to ask you, based on sa ating debate, okay, what is the topic of our debate this afternoon? Who can give me the title? Who can give me? Anyone? Okay, dito sa ating
Our topic for today is about resolve that synthetic division is an easier method than remainder.
That's our title. Okay, another question. What lessons you have learned from this debate? Anyone can give me? What lessons have you learned from this debate? Okay, anyone? From our audience. Okay.
Napareho sila sa shortcut, hindi napareho.
Okay, they are the same. So yes, di ba? So the synthetic division and the remainder theorem are just the same. They are the methods in finding the remainder. So in finding the remainder of the polynomial, you can use the remainder theorem or you can use the synthetic division. So therefore, it's your option which of the two methods you are going to use. So it is in your own way which you prefer. So if you prefer to use synthetic division, it's your option, or if you prefer to use the remainder theorem, it is also your option. So it's a matter of your choice. Okay, did you get?
Yes, sir.
Okay, so once again, let's clap our hands together. And good afternoon once again. And congratulations.
Wala exam! Wala exam! Wala exam! Wala exam! Wala exam! Wala exam!
Ito natin mamaya kung ano ang result.
Si Sir.